right, guys. So normally I'm always doing like either application security or network pen type stuff. So when I submitted the stuff here to Vic, Vic was like, hey, why don't you do some stuff on exploit dev? So I figured, yeah, why not? So any of you guys debugger monkeys? Anybody live the debugger life? Anybody all about some IDAPRO, some WinDebug? How many of you are like, okay, that's assembly? Anybody? All right, all right. So if you're in that, okay, that's assembly, this presentation's for you, okay? All right, guys, so what we're going to try to do is just start with a real simple vulnerable server. So we start with a vulnerable server. It runs on port 9999. You utilize this to get people started with exploit development. All it is it just echoes back whatever you do to it, right? So it'll act like a web server. It'll kind of act like a mail server. So let's say I grab my command prompt here. You see if I connect to it, it just says welcome to the vulnerable server. And then here you can see that connection to it, right? So hey, I received a connection from this IP. Awesome. So if you type help, you get a list of functions that the server supports. Now this is going to be just like a web server, right? You netcat into it, you get a list of all the options that the server supports, head, get, put, webdav, propbind, all that kind of stuff. Same thing like a mail server, receipt to, and all that kind of stuff, right? So some people call these methods. So you're looking at this, you say, okay, I'm going to send trun and srun, ltime, and then it's going to accept some parameters after that. So we need to fuzz. Okay, so customer gives you this vulnerable executable. You're going to notice, important for later, vulnerable executable comes with the exe itself and a DLL. So we're going to jump in and write some code for it. So we will use my beloved language Python. If you don't like Python, you're free to leave right now. Like, I'm really not kidding. You can get out if you're not cool with my beloved language. Okay, guys, so real simple code here. I would say as far as exploit development goes, you really won't write anything more complex than this. So for those of you who are worried about, oh my God, I got to be the ninja programmer, hell yeah, both. Thank you.
You're welcome.
Thank you. These are the CarolinaCon signature drinks? No shit, which one's which? I guess it really doesn't matter, huh? That's good. All right. Damn, that's good. Okay, so when we see buffer, buffer's value is A. We see counter, counter's value is 50. So everybody simulate when I see buffer, say A. Okay, ready? Buffer. Good, good, good job, good job, good job. Okay, counter, say 50, counter. You guys are awesome. This is great. Okay, while the length of buffer, buffer's value is good. So since while the length of buffer is less than or equal to 100, we're going to append times, awesome. That gives us 50 A's. And now what's going to happen is we're going to say counter equals plus, great. And now we're going to loop right back up here because buffer's new value is now 50 A's, which is still less than or equal to 100. Everybody with me? Close enough. Damn, man. God, dog. Some people. Okay. All right. So you're going to keep looping through here until this is greater than that, and then we jump down here. Now, Python has this cool data type called a list. So when you have code that's in brackets like this, we call that a list. So you see that this is just a list of commands. These are all of the commands that we saw that the server accepted. Everybody with me? Too easy. Okay. So now what we're going to say is 4 commands. So for each one of these in this list, and then we're going to do a nested for loop. 4 buff string in buffer. So the first time when buffer was A, And then the next time when buffer was 50, and as it kept incrementing, we're going to say, hey, for each time that it increments for that whole string, do this. We're going to say print fuzzing. You're going to print the command, and then string length, so it'll be fuzzing help 1, fuzzing help 50, right? And it's going to keep going. Now, this line right here is how we instantiate a socket object. You can remember that, or you can remember whenever you need to connect to an IPM port, you need that line. What works for you? That line, cool. So whenever you need to connect to an IPM port, you need that line. Now, after that, you can just say s.connect, throw in the IP address and the port number. You'll connect to that port. This just receives that banner. Remember how it says, welcome to vulnerable server? You're going to catch that banner. Then you're going to send the command plus the buff string. That's it. So, we have our vulnerable server running. We run our simple fuzzer. Does everybody see that bad boy's having a good old time? And then it went kablooey. Now, this is the cool part of pen testing, because now you get to go to the developer and say, I broke it. It no worky. Which is what we wanted, right? So, let's start that bad boy up again. Let's run this sucker again. Damn thing keeps blowing up. Okay, so if we notice that it keeps blowing up, what we want to do is we want to start the server, then we want to start a debugger. Now when we start our debugger, relax people, it's assembly time. Okay, so what happens is we're going to attach to this process. So we'll say, okay, I need to find vulnserve.exe wherever it may lie. I think I found it. And we're going to attach to it. And then voila, whoo! Let's go dive into some assembly. Everybody feeling good about that? Yeah, woo! I can't think of anything I'd rather do in life than assembly. Not. Okay, so when you're looking at this stuff, this is the nasty stuff. Everyone sees this and they're like, oh my God, this is disgusting. This is horrible. This is worse than marriage. This is bad. This is bad. It's almost as bad. It's really close. But the problem with this is when you get out of assembly, there's no alimony. There's no child support. I'd rather do assembly than marriage. That's all I'm saying. That's all I'm saying. Okay, so for those of you who did not have the misfortune of taking assembly in college, we're going to do about 30 seconds of assembly. Now, you have a workbench. Workbench. Everybody with me? Everybody, go workbench. All right, whenever you need to do work, you have to put whatever you're working on the bench. So if you need to put something on the bench, you push. Cool? Now, if I want to work on it, I call it. With me? So if I need to push something else on it, I push. If I need to push something else on it, push. Push. Now what if I need to interact with this one here? What do I have to do? Pop. What? Pop. And then what? Ret or call. Make sense? So when you got this, the thing about assembly, even though people make it sound like it's the scariest thing known to man, it is, but the benefit of assembly is it can only do one freaking thing at a time. You know what I mean? This is it. This is it. I can handle this. This shit doesn't shop. This shit doesn't want, I'm telling you, look, I can deal with this. I can deal with this. Look, all it can do, right? Now, everywhere that you have a register, that's a different workbench. Everybody with me? So if I need to push something into ESP, into the stack pointer, that's just another workbench. If I need to compare something that's in ESI, the stack index, with what's in the stack pointer, that's just comparing what's in two different workbenches. Make sense? If I need to LEA and load the effective address of something in one workbench and compare it to another, you guys starting to see what's going on? Assembly can only do a few things. So as long as you got that, shit's easy. Okay, so left side of the screen, assembly. Right side of the screen, registers. Okay, remember, those are workbenches. Now, our workbench that's most important is this guy called EIP, Extended Instruction Pointer. He's the guy who says what's about to happen next. Okay? Now, for those of you like ultra nerdy people, be quiet. Okay? Don't confuse the newbies. Okay? All they care about right now is EIP says what the hell's about to happen next. Cool? All right. Bottom left corner, bottom right, this is the stack. Okay, so this is ESP, the extended stack pointer. So whatever's going on down here, the major workbench that we do the bulk of our work in, that's where you're going to see it. Everybody with me? All right, this is cool. Okay, now I've attached to my program, and now I'm going to run that fuzzer again. Because after we broke it, we want to be able to talk about how well we broke it. So we want to sound intelligent. So I'm going to run the thing. And it looks all kind of pretty, doesn't it? Boom, it blew up. Now, whoops. You'll see down here, we got an access violation while executing 41414141. Doesn't it sound all cool? Now we can go up and we can look in our debugger, and we can look in the registers. What's about to run next? 414141, the letter A, right? So your computer is like, what the? Because he doesn't know how to run the letter A. That's why he crashes. He's like, dude, I don't know what the hell A is. Write it in assembly, man. If it were pushing or popping or something like that, I got it. I don't know about these damn 414141s. That's why he crashes. So we got our 414141s into what's about to execute. Everybody, next. Damn it, people, let's try this again. Hold on. All right, hold on. All right, EIP is what's about to execute next. We got our 414141s into what's about to execute. There you go. Damn, I'm not drinking enough for you guys, huh? Okay, so everybody, Control F2 restarts the program. F9 gets us back to where it's actually running. So we've restarted the program. Now what we need to do is we need to isolate the crash. Now we fuzzed each one of these different vectors into the application. What we want to do now is we want to tell the developer, okay, we've now isolated this crash. So we're going to send what, guys? Buff string equals what? How many of them? 5,000. We're going to send a lot of damn A's to this thing. Okay? Now remember that line. What do we need that line for? That's how we connect to IPs and ports, right? All this stuff look familiar? Okay, the only difference is now we're just sending the T-run, and then what? 5,000 A's. So this script isolates the crash. So if we run this, we should see EIP should have 41414141, right? So we hit it, boom. 4141414141. Okay, so what's about to run next has 414141. And then what about in the stack, ESP? If we look in the stack, is it full of A's too? Okay, if we look in the accumulator, EAX, is it full of A's? Okay, cool. Now remember, if you want to look down in the stack, you can look down here. Is it full of A's? Okay, so all of memory is just full of A's. You just took A's, you just poured it every damn where. Okay? All right, so this is how most people think of a buffer overflow, right? 12-ounce cup, 64-ounce cup, pour it, shit spills everywhere, and they go, okay, that's a buffer overflow. And no, that's a denial of service. All you did was crash it. So now what we need to do is we need to figure out EIP, what's about to run, is only 4 bytes. It's only 4 bytes. So if it's only 4 bytes, then we need to figure out, okay, man, where in them 5,000 A's is the 4 bytes that make up EIP? Everybody with me? Okay, now, for those of you who are ultra nerdy in math, we could do something called binary diffing. What we could do is we could send 2,500 A's and 2,500 B's. Okay, what the fuck? okay, we could do binary different. We could send 2,500 A's, 2,500 B's. And then we could look in EIP, and if we saw 41s, we would know it's where. In the first 2,500, if we saw 42s, we'd know it's in the second 2,500 bytes. And then we can keep chopping that in half, and within 7 iterations, we would come up with the 4 bytes that equates to EIP. Any of you math nerds excited about that? That's awesome. Woohoo! Can't think of anything I'd rather do. Yep. Okay, not. Okay, so we control F2, F9. We're going to attack this problem a little bit different. What we're going to send is a buff string that looks a little conspicuous. What are we doing to the buff string, guys? Okay, we're sending a cyclic pattern, right? Capital A, lowercase a0, capital A, lowercase a1, capital A, lowercase a2, right? We send this cyclic pattern, and then we look at whatever's in EIP, and then we calculate the distance to that. Everybody with me? Because it's either that or do that binary different thing and start chopping it up, and I don't know about y'all, but I'm not feeling that, right? And then the other problem that happens to me is I usually do this while I'm drinking. So the longer I go into this process, for some reason I start to experience diminishing returns. I don't know. Did y'all hear that? That has got to be the most smartest shit I probably ever heard. Were you high when you came up with that? No, you know what? Y'all are family. We can talk about this. Have any of you guys ever had that where like somebody drops like some like Albert Einstein type shit when y'all are fucking hitting a little bit of bud? I mean, look. I'll turn off my microphone. Y'all can, all my recording devices are off. Has that ever happened to you? Where you look over like, damn, man, how did you come up with that? That was one of those. All right, back to focusing, back to focus. Sorry about that. I get to, you know, you guys know what I'm talking about. Okay, so this is running, I'm gonna run that 3,000 char script, and then when we look in here, we'll see that we now have 38, 43, 6F, 39. Okay, why did I read it backwards? Huh? Little Indian, size does matter, right? So we need to, what? That's funny. We need to read from right to left, right? So it's a 38, it's a 43, it's a 6F, and it's a 39. So we need to try and calculate the distance of that. So control F2, F9. Let's look at our next script. So now we've realized that 38 is the number 8, that 43 is the letter capital C, 6F, lowercase o, 39 is a 9. That's all hex. This is the ASCII equivalent, right? So what we need to do is we need to search for this string. Once we find that string, we chop the code off right at that string. And then we just print the length of buff string. Everybody with me? Okay, so when we run this bad boy, it tells us that it's what? 2006. So from your point of entry into the application, 2006 bytes, that gets you right to EIP. So we need to test it, don't we? Okay, so let's test it. So we say, all right, let me close that bad boy up, crack open this guy. And what's the script code doing, guys? That's it. So if this works, I'm sending 2006 A's. My EIP override is BBBB. That'll be 42, 42, 42, 42. So you're seeing I'm sending the trun function, the 2006 A's. Here's my EIP override. Now, EIP is what's about to run next. So if we can control EIP, then it's going to try and run our 4Bs. Everybody with me? So if I double click on that bad boy and you look at EIP, what's it looking like now? Yeah. So now, have we proven that we have control of EIP? Yes. Here's where it starts to get real freaking cool. Now, we want to tell the computer, hey man, open up a freaking command prompt, right? The problem is, open up a freaking command prompt, technical term. Open up a freaking command prompt does not fit in 4 bytes. Yeah, no worky, okay? So what we gotta do is we gotta find some space that we can put, hey dude, open a freaking command prompt, technical term. And then we wanna say in EIP, jump to, hey dude, open a freaking command prompt, right? Technical term. So we go, okay, I'm going to go back and rerun the previous script. So Control F2, F9 a couple of times. I'm going to rerun this guy. I want to see if you guys notice something. Do we have A's in the stack? Yes. Okay, so I need you to think right here. Okay, this is EIP. Dave, stand up, EIP. EIP, cool, got it. Have a seat. All right, now, point of entry into the application. You start laying down A's. A. I get to EIP, I put in what? B's. Immediately after EIP, simulated ESP box. From here, we have nothing but A's. So, do I have space behind EIP and in front of EIP that I control? Anywhere that you've written A's is an area of memory that you control. So this is why you'll see people try to write past EIP. They need to control EIP, but the more that they write past it, while keeping the application stable, that gives them more places to jump to for their shellcode. Everybody with me? Cool. So what we want to do is we want to find something that says, hey dude, jump to ESP. Because if we jump into the stack, that's where our A's are, right? So let's jump there. So what I'm going to do, I'm going to Control F2, hit F9. Now, you see this E? I'm going to double click this E, and now we see all the DLLs that are loaded. Okay? Here are the system DLLs, and then here is a third-party DLL. Now, how many of you guys have used Metasploit or any exploit, and you see that it says it only works on Windows XP Service Pack 2, or Windows 2000 Service Pack 4, or Windows Vista Service Pack 1, right? What's happening is the attacker is most likely using a system DLL. And when the system DLL changes during service packs, that throws off everything, so the exploit only works on that service pack. If you were to use a third-party DLL, then it doesn't matter if they change the system DLLs, because the addresses you're using are coming from here. Make sense? Okay, so we're going to do that. I'm going to jump into ESSfunc.dll, and now that I'm in the DLL, you can see I'm looking right in the assembly code of that DLL. So I'm going to say, hey, I'd like to look for a jump ESP. Now when I find that, you'll see that I found it at AF115062. Right? Here's my first jump ESP. So what I want to do is I want to set a breakpoint on that. So when the application's running, if I set a breakpoint, when the code hits this point, that breakpoint is going to go from red to black. Code. So let's look at our source code. So now you're seeing that we're sending 2006 A's. Here's our jump ESP written bass-ackwards, right? It's got to be written bass-ackwards so that the computer understands that. For some reason, Little Indian likes to be read bass-ackwards. That's cool. Now we're going to backfill 990 bytes. So if you look, 2006, that's your buff string. Your ret is only 4 bytes. After that, the remaining 990 totals us out to 3,000. So if you see what we're sending, T-run, buff string, ret, and then here's the buffer backfill. So as soon as we hit this, we should jump smack dab into this. Yeah? Let's check it. So that breakpoint right here, that was your fault? Oh, appreciate that, man. You're looking out. Thanks. Serious. Okay, so this is just a bind shell. That's all this is. And now we're accounting for the space in the bind shell. So here we're sending the T-run, we're sending the buff string, we're sending the jump ESP, the ret, and then I'm adding 16 NOP sleds. Lazy. I'm just lazy. ESP is usually 4 or 8 bytes away from EIP. So how many NOPs did I put in? 16. So if it's 4 bytes away, I'm going to land in what? NOPs, right? Because I have 16 here. So if ESP is at 4 bytes, what am I going to land in? NOPs. If ESP is at 8 bytes, what am I going to land in? So is this lazy? Yeah. Yeah. I don't care. Call me lazy. I don't care. That's all that matters. That's all that matters. So you land in here, you should slide right into your payload. So we're going to run this bad boy. I'll run it. And let's change that to port 4444. And we've got our first shell. All right. Ladies and gentlemen, you've popped your first box. Oh, okay, I did. But, you know, was it as good for you as it was for me? I know it was good. Okay, so most of us have seen that before, right? Most of us have seen a generic Stack Overflow before. For those of you who haven't, welcome to the club. You've now seen a generic Stack Overflow. Where it starts to get interesting is some of these other types of overflows, like structured exception handlers, heap sprays, ROP, all that kind of stuff. So let's try and go through some of that other stuff right now. Now, right now, I'm going to have to yell, okay?